Let's talk about a silent production killer, that background job secretly slowing down your user-facing APIs.
So the complaints roll in. Your users are saying the app is sluggish, maybe even timing out.
But here's the mystery. You checked your dashboards and API latency looks totally fine. What gives?
Well, the problem isn't your API code. It's a resource conflict happening just out of sight. We call this the noisy neighbor problem. One process is just hogging all the shared resources.
Okay, so the first instinct is, can't we just run this in a separate thread?
That's a trap. Thread pools fill up fast, and in Python, the GAL means no true parallelism anyway.
So we have to figure out where the actual fight is happening. Let's investigate the contention.
Your API and the worker are battling for CPU, database connections, disk I/O, you name it.
Now, before we pick a fix, we have to think like an experienced engineer about these real-world constraints. All right, strategy 1, temporal isolation. Basically, just run the job when no one's around. This is great for nightly reports, but totally fails if the user needs to see results now. Okay, strategy 2, physical isolation. We give the background worker its very own dedicated machine.
This gives you perfect isolation, but it's expensive and adds a lot of operational complexity.
And that brings us to the balanced approach, logical isolation, using asynchronous task queues. You get incredible flexibility and reliability. The catch? You have to manage a message broker.
So for most high-scale systems, the recommended design is the async task queue. Here's how it works.
See? It hits that sweet spot, high scalability and isolation, but with manageable cost and complexity.
The key is it decouples your system. You can scale workers without ever blocking a user request again.
So here's the golden rule. Don't let your background work ever become a foreground problem for your users.